Hello viewers, you're welcome to this video series for chapter 12, section 12.3, 12.4, which is hyperbola. Let's start with the definition of a hyperbola. We say that hyperbola is the set of all points in a plane. The difference between whose distance from the two fixed points is a positive constant. So we'll talk about that later. Now, what is more important about a hyperbola is there are two axes. We have what we call the transverse axis and the conjugate axis. So if you remember ellipse, in ellipse we have two axes. We have what we call the major axis and the minor axis. But in this case, we have the transverse axis and the conjugate axis. So what is the transverse axis? The transverse axis is the line segment joining the intercepts. What do we mean by this intercept? For example, in this case, this is a hyperbola. We will discuss what type of hyperbola is this. Now, you see these two curves. So these are the intercepts here. These are the intercepts here. So the intercept simply means where this curve cuts the words. You can see in this case, cut the x-axis. So the transverse axis is the line. So this from here to here is what we call the transverse axis. So you can see in this case, our transverse axis is the x-axis. Then the other one is called the what? The conjugate axis. So this is the conjugate axis here. All right. So then we can talk about the center. What is the center? The center is simply the midpoint of what? The transverse axis. So if this is the transverse axis, so the midpoint here is called the center of the transverse, of the center of your hyperbola. Now, another thing we can see from here, you can see that the distance between these 2 points is simply going to be the distance of what? Of 2a. So that is the distance between these 2 points here. Then we also have what we call the conjugate axis. So you can see the conjugate axis is this one. Then we have the foci. The foci is simply a distance of c. So if this is your origin, if this is the center, the distance from here to the first focal point is c. The distance from here also to the second focal point is also c. So the distance between two focal points is simply 2c. All right. So now this intercept is actually called what we call the vertices. So we said the vertices of a hyperbola are the points where the hyperbola intersects the transverse axis. So in this case now, these are the vertices. This is vertex 1 and this is vertex 2, right? So the distance between two vertices is, so let me put it this way, the distance between vertex 1, vertex 2, it's simply given by 2a. Also, the distance between focus 1 and the focal point 2 is given by 2c. All right. So, but there are two types of hyperbola. We have the horizontal hyperbola and the vertical hyperbola. So now let's discuss about hyperbola where the center is what? Is origin. So if you look at these two cases now, this one is a horizontal hyperbola. Why is it a horizontal hyperbola? Because the transverse axis, this is the transverse axis, is the x-axis. So if the transverse axis is the x-axis, it means the hyperbola is what? Is horizontal. So if the transverse axis is the y-axis, so you can see in this case now, this is our transverse axis, this one, okay? So now let's focus on the horizontal. If this is your transverse axis here, then look at the curve. So this is this. So it means this point here is our first vertex, which is A0 because it's on the horizontal. And this second vertex here is going to be what? It's just going to be this one. You can call it This is going to be V. You can say minus A and what? And 0. All right. Then the conjugate axis is going to be this one here. It's going to be the conjugate axis. So this midpoint here is simply the center of the hyperbola. So same apply to this one. Now in this case, this point here is going to be our first vertex, which is going to be 0A. Why is it 0A? Because it's on the y-axis. And this one here, you can call it 0 minus A because it's also on the y-axis. So then we have formula for that. The standard equation is x squared over a squared minus y squared over b squared is equals to 1. Now, one thing to note here is unlike in the case of ellipse, here there is no condition that a has to be greater than b. No. All right. So we just look at what the a is always associated with what? The positive. So whether it's the smallest or is the biggest, a is always associated with, you can see here, this is not plus, this is negative, right? So you can see that this a is associated with the x-axis. So it means it's a horizontal hyperbola. Here you can see here, a is associated with the what? With the y. So it doesn't matter whether a is the smallest or is the biggest. As long as it's the one associated with y, then it means this is a what? This is a vertical, hyperbola. All right. Then another difference is how to find c. In the case of ellipse, it was what? C squared is equals to a squared minus b squared. But for hyperbola, it's a squared plus what? Plus b squared. And the endpoint of the conjugate axis is just this one. And another important thing is what we call the what? The asymptote. So we have two types of asymptotes. For the horizontal, this will be the slope of the asymptote. So this is our line of asymptote. Then for the vertical, this is A over B, not B over A. So what are the asymptotes? The asymptotes are just these lines here. So for example, in this case, you can see two lines. You can see two lines here. This one, this is an asymptote, and this is also an asymptote line. So these are what you call the lines of asymptote. All right, so we're going to see how to sketch this. Then we have what we call the length of the transverse axis, which is twice A. The length of the conjugate axis is twice B. And so this is the definition. When we started, we said that what? The difference of the distance between any point and F1, the difference is simply given by what? 2A. So here you can see is a you have to take the absolute value. So it means if you take any point on a hyperbola, you find the distance of that point to the first, okay, let me just illustrate this from here. What it means is that, for example, if you take any point, here, you find a distance, okay? So you can find the distance from here because this is your F1, maybe this is your F2. So you can call this P, call this F1, and call this one F2. So what it's saying is that if you look for the positive distance between Fp and F1 minus P and what? F2, if you take the absolute value, it's going to be just twice of what? Of A. All right. Which is simply twice of, which is just like what? The length of the transverse axis. So it means the distance from here to here and the distance from, let's say, this point to this one is going to give you, when you take the difference of the distance, it will give us twice the transverse, or it should just give us the length of the transverse axis. Then another thing here is what we call the eccentricity. Eccentricity in this case is defined as C over A, which is greater than 1 because our C is always greater than A. In this case, remember, C squared is what? Is A squared plus B squared. So C is always greater than A. Therefore, this ratio C over A is going to be greater than 1. Now, if it is very close to 1, then you're going to have a thin hyperbola. But if it is close to infinity, if it's a very big number, then your hyperbola is going to be a little bit wider. Let me just give us an example. For example, if you have this one, you can have, if it is very close to 0, very close to 1, you can have something like this. Right, let's see, for example, okay. And then if it is very close to infinity, then it's going to be very wide hyperbola, something like this. So, all right. Now let's take examples. And so for example 1, here we're dealing with only cases where we have a hyperbola that is centered at origin. So let's start with the first one, A. Okay. So here we have y squared over 9 minus x squared over 4 is equals to 1. So let's just take it there, equals to 1. And now you can see that what is going to be, this is directly a vertical. So this we can write it as y squared over 3 squared minus x squared over 2 squared is equals to 1. So this is nothing but a vertical hyperbola. Why is it vertical? Because you can see the positive is y. It's y that has the positive. So it's going to be vertical. And therefore, you can take a. So a squared is just 3 squared. So which means that a is equals to 3. B squared is equals to 2 squared, which means that b is equals to what? 2. So therefore, we can have c squared, which is a squared plus b squared, which is just 9 plus 4. And that implies that c is going to be the root of what? Root of 13. All right. Now, let's try to sketch this one before we try to get everything. But so now to sketch this, what do we do? Let's just try to sketch it directly first. It can have something like this. So remember, this is centered at where? It's centered at origin. Now, since it's centered at origin, this is our center. And you can see we know it's a vertical hyperbola. If it's a vertical hyperbola, it means our transverse axis is going to be the what? The y-axis. So it means our A will be on the y-axis. So it means if I call this one 1, 2, let's say 3. So where is A? A is 3. So this, we will have a point here. And this point is what? 3, 0. And then we will have another point, let's say 1, 2, 3. So this point is minus 3, 0. Okay. Then we will have A is 2. So let's take A to be 2. So let's say 1, 2. So this is going to be 2, 1, 2. So this is minus 2. Okay. And we're almost done. So here now we will have this here. So what is this point? This point is going to be our our vertex. So this will be our vertices now. So this will be our V1. And this will be our V2. Okay. Yeah, V1, V2. Then we also need what we call the focus, right? So, but before we do that, let's do something here. Or let's do our focus. You know, our focus is just going to be a distance of C from the what? From the center. So if you come here, this is root 13. So let's say root 13 is going to be bigger than 3. So let's just say somewhere here. So this is going to be our F1, which is simply going to be, no, sorry, this is not going to be our F1 because our F1, look, our F1 must also be where on the transverse axis. And what is our transverse axis? Is the y-axis. So if this is our what? If this is our vertex, so it's going to be somewhere here, which is going to be root of what? 13, 0. And then maybe somewhere here, which is minus root of 13, 0. So call this one our F1, and this one is our what? F2. All right. Now, what do? We need also the asymptotes, but before we do the asymptote here, we can just do, this is just for, you can do this one. Just try to connect the two vertices. You will draw something like a triangle or a rectangle. And I will tell you what is the importance of that. Okay. Now you can see the rectangle I drew is simply from where? You just simply, you go a distance of the vertex to the up, and also a distance of what? The transverse. So now this is our conjugate. Don't forget, this is the length of the conjugate axis. And this is what? The length of the transverse what? Axis. Now, I will draw something which we call our asymptote, line of asymptote. So our line of asymptote, you can just connect the what? Connect the corners of your rectangle. Just keep moving here, down here. And it must pass through the what? It must pass through the center. Okay, just something like this. All right, now we're almost done. So now we need to draw the hyperbolas, the curves. Now, how do we draw the curve? The curve, it's simply going to be somewhere. Remember, this is our vertex, this is our V1. So just draw a curve and let it come close to your what? Let it come close to the hyperbola, right? Repeat that same here. This is our vertex. Look, this is not, we're not drawing the curve from the focus. We're drawing it from the what? The vertex. So just something like this. Just close. Remember, these are the red ones are the asymptote line. So it just come close, and that will be it. So once you're done, you can remove this your triangle if you want. This is just to give you a rough sketch. Just draw your asymptote and make sure it doesn't cut. It goes closer to the curve. All right. So this will be the rough sketch of these hyperbola. But let's see. Since we're asked to find the coordinate, we need to find the domain and the range. So let's bring out all these parameters here. So here, just like from the diagram, you can see we have our center. The center is nothing but 0, 0. And we have the vertices. Remember, the vertices will be on the transverse axis, which is supposed to be 0 plus a. So it's just going to be 0 plus of what? 3. As you can see, we have two vertices. Then another thing is that we have the foci, which is also going to be on the transverse axis. So it's 0 plus minus c, which is simply 0 plus minus root of what? Root of 13. Then you can find the endpoint. The endpoint of what? The conjugate axis. Now, since our transverse axis is the y-axis, the conjugate axis is going to be the x-axis, but now it's going to be plus minus b0, which is simply plus minus 2, 0. So it is this one here, the line in green here. Yeah. That's the x-axis, on the x-axis. Then we can find the eccentricity. Centricity is what? Is E. Centricity is E is equals to what? C over A, which is, what is C? Which is root 13 over what? Over 3, right? Then we can find the asymptotes. What are the asymptotes? The asymptote in this case is going to be plus minus A over BX. So this is just plus minus, what is A? A is 3, so it's 2 over 3x. So we have actually two asymptotes. It means we have y is equals to 3 over 2x. And what? Y is equals to minus 3 over 2x. So these are the two lines. The one is positive slope and one is a negative slope. So these are the two asymptotes. Then we can talk about the domain. So these are the slope of the asymptotes, 3 over 2 and minus 3 over 2. Now the domain is talking about the values of x, right? And as you can see, this hyperbola is increasing. This is going here, right? So it means x can be from where? Minus infinity to infinity. But if you talk about the range, what will be the range? The range is the values of y. You see, it's going to be, there is a space here. Remember, we're not taking the red lines, the asymptote, when you are considering the range, yes? So it means you go from minus infinity. The lower part is going to be from minus infinity. Then you stop here, which is minus 3, right? So minus 3 close, union. Then you go to the upper path, which is going to be from where? 3 to infinity. All right, so that is that for question A. So let's take question B. So let's take B. B is what? B is 64 x squared minus what? 9y squared is equals to 144. So the first thing is that we need to bring it down, right? We need to transform it to the standard form. That we can easily do by dividing by 144. And that will be 1/6 over 144 x squared minus 9y squared over 144 is equals to 1. And this is just going to be, we can divide by what? By 16. Yeah, so this is 4x squared over 9 minus, and this by 9 also will go. This is just y squared over 16. This is equals to 1. And then we can rewrite this as x 9 over 4 minus y squared over 16 is equals to 1. So here you can see now we can rewrite this as what? We can write this as x squared over 3 over 2 squared minus y squared over 4 squared. So clearly, this is going to be a horizontal hyperbola. Now, why is it horizontal? Because the x is the one that is positive, right? So since the x is positive, what can we say? It simply means that what? We can take a squared is 3 over 2 all squared. And this implies that a is what? 3 over 2. If a is 3 over 2, then b squared is what? 4 squared. And this means that b is what? Is equals to 4. Okay. Okay, so now let's try to graph this one as well. So I'll attempt to graph it with before writing down these parameters. All right, so now to sketch this one, we know we're dealing with the horizontal, so let's see. For horizontal, it means our transverse axis is going to be on the x-axis, but the center, we know it's what? It's 0, 0. So the transverse axis is going to be on the x-axis, right? Okay, so since it's going to be on the x-axis, it simply means that here we'll have what's A is what? 3 over 2. So somewhere here, we're going to have 3 over 2. And somewhere here, we're going to have minus 3 over 2. Okay. Then what next? We know we're going to have the B is going to be on the y-axis now, which is actually bigger. So you can see that this is going to be 4 and minus 4. So let's say this is 4, 1, 2, 3, 4. And minus 4 is going to be 1, 2, 3, and what's minus 4? All right. Now we know what the focus will be, so we can find our focus, because from here we can find what is C. So what is C? C is going to be the root of A squared plus B squared, which is going to be, you have 9 over, it's going to be the square root of, yeah, so 9 over 4 plus 16. And this is going to be square root of, I think 73. And over 4, so this will be over 2, so plus minus. All right, so we know that our focus is going to be on this line, so this is going to be a very slight large number here, and also somewhere here. Let's just put it here. So let me call it F1. So this is root of 73 over 2, 0, and somewhere here, minus root of 73 over 2, 0. So this is our first focus, and this is our F2. This one here, it's the vertex. So this is a vertex V1, V2. And I think almost we're done. So let's, the same thing we did the other time. I would try to just create something like this. So this is not really, anyway, it's okay, but it's like a rectangle. It should be like a rectangle. Then you can draw just a line, draw it. You connect the corners as well. That line must pass through the center, right? Keep going. Then now let's draw the hyperbola. So the hyperbola, it must cut through the vertex, so V1, so it's going to be something like this one. Then just draw it closer to this here also, just to make sure it's getting closer to your line, your asymptotes. So you repeat that here also. Then so that's it. So this is like a rough sketch. You can remove these boxes now. Okay, so now we're done, but we can write down the parameters since we also have to find the domain and all of that. But you can graph it without writing. So let's write the stuffs down. We start with what? With the center. So what is the center? The center is 0, 0 still. And the vertex, remember this is A, is going to be plus minus A0 because we're dealing with the horizontal. So this is plus minus 3 over 2 and 0 as the vertices. Then we know the focus here is also going to be on the transverse axis. So it's going to be plus minus what? Plus minus C0, which is going to be plus minus root of 73 over 2, 0. And then we have what you call the endpoint of the conjugate axis. So our conjugate axis in this case is our y. So it means it's going to be 0 plus minus b, which is simply 0 plus minus 4. All right. Okay. Then we can also talk about the asymptotes, or we can talk about, yes, asymptotes is fine. Our asymptote here is going to be plus minus. Now it's going to be b over a, not a over b, right? So this, it's simply plus minus, what is b? B is 4 divided by a, which is 3 over 2. So it means that your y is going to be plus minus 8 over 3x. So this is our asymptote. So it means that these two lines that we have passing through the origin. So the one with the positive, so this means that the positive slope means the one that's rise. This one is nothing but y is equals to 8 over 3x. Y, this one here, now this one here, which is falling, is minus 3 over 3x, 8 over 3. Okay, then we can also find eccentricity, which is E is equals to C over A, which is C. What is C? We know what is C. C is just a big number here. Then you divide by what? Divide by A, which is 3 over 2. So this will give you this one. All right. Now domain. What is the domain? The domain is, now we have to look here. So domain is going to be, something is missing, right? So it's just going to be from minus infinity to minus 3 over 2. Then you jump, you skip. Because you look at it, there is like a hole here. So you don't have anything here on the x-axis. Then you jump to where? From 3 over 2 to infinity. So you have minus infinity to minus 3 over 2, then union 3 over 2 to where? Infinity. And the range is the one that is going to be from minus infinity to infinity. So let's go to the graph again. As you can see, what is the range? The range is the values of what? The values of y. So these values will continue because you remember this will keep going. Right, this is going here, this will keep going, this will keep going. So vertically, so y will continue, right? But if you look at this one, the x-axis, that is where there's the change, right? Because the domain cannot be minus infinity to infinity, because between minus 3 over 2 and 3 over 2, you can see there is no black curve, right? So the hyperbola is not there. It's like an empty space. So I think that is it for this one. Then we go to the last one, which is C. Yeah. So what is C? I think C has to do with a half hyperbola. We have x minus 3. It's equals to what? It's equals to minus 1 plus y squared over 25. So here, what do we do? This is simply, we can square both sides, right? Just to write it in standard form. We can square both sides to write x over 3 squared is equals to so what will this be? This will give us x squared over 9 is equals to 1 plus y squared over 25. And that simply means that x squared over 9 minus y squared over 25 is equals to 1. Right. Now, this is going to be a half. But okay, now let's see first. What is a? A squared is going to be definitely 9. And that means that a is what? Is 3. B squared is 25, which means that b is equals to 5. Now, what type is this one? You can see this is going to be a horizontal because the positive is associated with what? With x. So this is a horizontal hyperbola. Now, this is the full hyperbola, but what we're asked to sketch is not the full. We're interested in this one, right? So you can go ahead and sketch the full first, then we take the part that we need. So let's do this one here. This is just going to be like this. So this is a horizontal hyperbola. It means that what? Our transverse axis is going to be the x-axis. So our vertex will have to be on the x-axis. So, and what is the vertex? Since we know our A is going to be somewhere here, which is 3, 0, and minus 3, 0, right? Then the conjugate axis will be on the y-axis, which is going to be somewhere here. Let's call it 5, 5, 0, and minus 5 and 0. Then another important thing we need to get is the focus, so we can have our C. So what is C squared? C squared is just going to be A squared plus B squared, and that will be 9 plus what? Plus 25. Okay. Yeah, 9 plus 25, which is about root of what? Let's say 34, right? So C, I should put square here. So this is about root of what? 34. So it's going to be on the same axis here. So this is going to be our 34. And then minus root of 34, 0. So this is our F1. And this is our F2. This is V1. And this is what? V2. So the same story, we can just try to connect this rectangular. We'll go 3 horizontal, 3 wide, and vertical 5. So draw a line. Okay. Now we should have this coming from here. And same here. Through the vertex, not the focus, right? Okay, something like this. But now we're interested in only one path. So we're interested in the negative part of x. So x over 3 is negative this. So it means we have to delete this part. So we're not interested in this part. So this is the only part. So this is half. This is what we call the half horizontal hyperbola. Okay. This is half horizontal hyperbola. So here, we can try to bring out all the things that we talk about. It's going to be almost the same. So I think the only thing that will really change is those two things. So I'll only talk about that here, just to avoid repetition. Let's talk about the domain now. So what will be the domain of this? The domain is still going, it's just going to be from minus infinity to where? Yes, because this is going. So from minus, don't forget that this keep going. So it means the xy's, you're coming from minus infinity, you stop at where? Minus 3 close. And I think that is the only part because the other side is removed, yes? But the range, I think the range will still remain. The range is still going to be minus infinity to infinity. Okay, so let's move to another question. Question number 2. Example 2. It says, find the standard form of the hyperbola having vertices and passing through the point. Now, we're given the vertices here. If you look at these vertices here, the vertices is like what? It's like your A. So, and you can see the vertices is on the what? It's on the x-axis. So since the vertices is on the x-axis, it means you're dealing with a what? With a horizontal hyperbola. So let's see. We have vertices minus 5 and 0 and what? And 0. This implies that what we are all dealing with a horizontal hyperbola. Because for a horizontal hyperbola, we know that what you have vertices is what? It's going to be plus minus a0. Okay. So it means simply means that what? A is what? Is 5. So if A is 5, how do you write it? It's going to be x squared over what? Since it's a horizontal hyperbola, it means the x will be the one that is positive. So it's x over a squared minus y squared over what? B squared. This should be equals to 1. But we have what is a, so x squared over a squared will be 25 minus y squared over b squared is equals to 1. Then we use the point given. So the point, which is the point, minus 1, 3 is on the what? Is on the hyperbola, right? So you take this to be your x and this to be your y. So therefore, we will have 5 squared. No, not 5. X is minus 1. So you have minus 1 squared over 25 minus y, which is 3 squared, over b squared is equals to 1. And this will be 1 over 25 minus 9 over b squared is equals to 1. And then we try to solve this for b, right? So how can we do this? This will just be 1 over 25 minus 25 over 25. It's equals to 9 over b squared. Yep. So what would this be? So this is going to be 1 over 25 minus this. So this is simply going to be minus 24 over 25 is equals to 9 over b squared. All right. So what is b squared? This definitely is going to be a problem here because you're going to have a negative number, right? And this is 25 times 9. And this is going to give us b squared is equals to minus 225 over what? 24. Now this is impossible. Why is it impossible? Because B, you cannot find B, right? Because B is going to be, okay, let's say B is going to be the root of minus 225 over 24. So this is complex, imaginary, so it is impossible. So it simply means there is no what? It means there is no hyperbola that have these parameters. And that's it. Now, example 3. Example 3 says you want to find the standard equation of a hyperbola with asymptote. So these are the asymptote here, 2 asymptotes, yes? But from the vertices, look at the vertices. Where is the vertices? So vertices are what? 0, 4, and what? 0, minus 4, right? Now, what does this mean? This means that you are dealing with what? Because the A is on the y-axis. So this means we are dealing with a vertical hyperbola, right? Now, since you are dealing with a vertical hyperbola, what does that mean? It means that what? Your equation is going to be y squared over what? A squared minus x squared over b squared is equals to 1. And this means that y squared over, so this would be our A actually. So this would be A. So A is equals to 4. So this will be 16 minus x squared over b squared is equals to 1. All right. Now, how do we get B? We can get B from where? The asymptotes. Asymptotes is y is equals to plus minus half x. Now, since it's a vertical hyperbola, how do you find the asymptote? The asymptote is simply y is equals to plus minus what? A over b, x. Now, this simply means that what? A over b is going to be what? Half. And we know what is A already. A is 4. So you have 4 over b is equals to half. And that means that b is equals to what? B is equals to 8. So therefore, you will have y squared over what? 16 minus x squared over b squared, which is just 64, equals to 1. All right. So I think that will be it for this. So the next video, we'll be looking at hyperbola with a shifted vertex. Thank you for watching. Share with your friends, comment, and if you're yet to subscribe, kindly do that. Thank you once again for watching.